Hello everyone, I welcome you all to this tutorial on forecasting using Python. So in this tutorial, we will be we'll be using COVID-19 data, open source data that is available across the world on daily new cases, new deaths, and many other parameters that are related to COVID-19 patients. So we'll be using that data and try to use the past historical data and forecast for the future. And we will use a couple of different techniques and see how the performance in each of these techniques is with respect to the forecasting exercise. So let's get started. Let me first introduce the libraries that we are using. So I think you guys should be familiar with the standard libraries Pandas, NumPy, and Matplot for plotting visualizations. And then we are using a library from sklearn called mean absolute error to actually uh, diagnose the forecasting error of the techniques that we are using. And then we are using autocorrelation plot. I'll get there when we reach. And then we also use ARIMA model from stat models library because that is one of the popularly used techniques for forecasting exercises. And so let's first import these libraries. And I have the open source data loaded in Google Drive, and I'm importing that as well. So if you see, the data looks something like this, right? So this is the country code and the country name, and on daily basis, you have data into 2021 as well, and then new deaths for that day, new cases, and how many tests they have done, how many vaccinations we have done, and many other parameters. But for simplicity, we are just going to consider new deaths alone in this particular data. There is a possibility you might also be familiar with this data in the prior exercises. So let me first see how many countries are there in this particular data. So I could see that there is India, Israel, and Japan, right? So we cannot forecast for all these three countries together at one go. So let me first consider one country at a time. So maybe we could start with India. So I'm filtering the data set only for India in this particular line. And then I'm just looking at the timeline of this particular data. So I can see that I have data from 16th Jan 2021 till 5th of maybe July 2021. It's a very recent data that we have for about six months, I believe. And then let's first have a look at how the data is spread across. So I am using only new death of all the columns. So from here onwards, the column of focus is new deaths on daily basis. So we could see that the new deaths were at minimal in the start of the year, and then it surged crazily around May. And in June, particularly, we could see that it had the highest surge or the peak, and then it slowly got controlled and it started falling down around July. Right, so this is the time series data we have, and now what we are going to do is we are going to use the historical data and try to forecast, like use the past week of new deaths and see for in the next weeks how many new deaths on a daily basis could we expect. So we could use multiple techniques. So I wanted to start off with the most naive way or the basic way in terms of forecasting, which is just rolling mean averages, right? So if I have 7 days of data, what rolling average means is that if I say 5-day rolling average or moving average, I take the average of the past 5 days. So if today is Friday, I will take the average of Monday, Tuesday, Wednesday, Thursday, Friday. And on Saturday, I will take the average of Tuesday, Wednesday, Thursday, Friday, Saturday. So for every day, I take the past 5 days average, and that will be my prediction. And that's a 5-day moving average. Similarly, you can have a 10-day moving average, 15, 20, whatever day. It just means that you are taking the average of the past 10 days, and that's your forecast. It's a very simple technique that's very widely used, particularly in trading and stock market indicators. So I'm going to use that technique first to forecast. So I'm having, there is a pandas function called rolling, which computes this rolling average, and you have to just specify the window. So this means it's a 5-day moving average, and then 10, 15, and 20. And then what I'm doing is I'm assigning color to each of these moving average based predictions, and I want to visualize along with the original data how does it look like. So you could see that red is the 5-day moving average, and that is very close to blue. So as we increase the historical window of computing moving averages, we could see that it is doing a little better, or it's bad or worse. It's deviating from the original quite a lot compared to shorter windows. Which so you could see from this visualization, 5-day moving average is the best possible thing. Right. So I'm saving these into new columns in the Panda so that in the future we can see how good are these predictions with respect to the actuals. And so I'm dropping NAs particularly. Reason we might have some NAs right now. For example, for computing 5-day moving averages, I could have my first prediction only on the 5th day, because on the 4th day I cannot have the past 5 days data, so I cannot make any predictions, and it's going to be NAs. So when you do moving averages, there will be some NAs for those rows for which predictions are not possible. So I'm removing those NAs right now. Now I want to use other techniques like ARIMA to forecast future data. So, but to use techniques like ARIMA, which is auto-regressive integrated moving average, so what does is that it's just a regression with respect to past lag variables, right? So I want to, or if you are doing a moving average, you in this case I just tried with 5, 10, 15, 20. But how do we come up with these numbers? Like, who tells us 5 is the good to start with, 10 is the good to start with? To have an understanding of that, we have something called as the autocorrelation plot. So this autocorrelation plot actually tells you for each lag. So x-axis is the lag, 1 day, 2 day, 20 day, 40 day, 60 days, so on. For each lag, you know how much is the correlation of the actual data with respect to the lag. So there is a dotted line you could see in this visualization, which is actually the statistical significance. So the lags that are above these dotted lines are significant lags with respect to original data. So we could see that very shorter lags are actually significant, but as we increase the time window, it's getting very bad. And after 40 days or so, we could see it's negatively correlated. So which means if it was very high 40 days before, today it will be very low. So it will be totally opposite. And the same plot, I am just making it to a confined window. So here it is like 120 lags I have considered. So for visually to be appealing, I'm just considering only about 50 years here. So again, it's whatever that's above the blue levels are nothing but significant lag. So we could see from this that either a 2-day, 3-day, or 4, 5-day lags are good. Anything other than that is not good. So which was reflecting from this particular moving average as plot as well, as it is very closer 5-day, it's good. Otherwise, other lags you could see it's pretty far away from the blue, which is the original data. So having said that, now let's do an ARIMA model. So this is the ARIMA model, and it has some parameters which are nothing but how many lags to consider, how many moving averages to consider, and this you could consider always as zero in a simple ARIMA model. I'm not getting into detail. So let me just consider a simple ARIMA model with just one lag, So we could see I'm using only one lag to make the prediction, and we could see that lag is significant. And if I do the same with 5-day lags, I will get an ARIMA output for 5 days, and these p-value says whether these outputs are significant enough or not. So we could see that lags 1 and 2 are significant. The remaining lags are not significant, which means that they are not that great. Only the first lag and the second lag are significant enough in forecasting the actual data. Now, having trained that ARIMA model, I am splitting my data into train and test. The way I'm doing it is I'm sorting the data by time in descending order from old to recent. I'm using the for 90% of the data to train my ARIMA, and then use that to forecast for the remaining 10% of the time. This is a small loop that I'm doing to make my predictions. right? So, and I will also report my mean absolute error in terms of my prediction. So in this visualization, you could see blue is the actual and red is my ARIMA forecasted data. And my mean absolute error is about 133.5. So plus or minus 133.5 is the number of new deaths I am miscomputing on an average. Now, if I compute the mean average error for the same test data, because that's when it's going to be apples to apples comparison in terms of seeing which is better, ARIMA or the moving average based ones. So for the same test data, I'm computing the difference between actual and predicted values and I'm reporting it. So I could see that for 5 day it is 110, the minimum, and as we go 10, 15, 20, it's getting worse. Meanwhile, the ARIMA 5 day is 133. So from these two, we could see the best prediction is actually a 5 day moving average, which is 110. And ARIMA is decent enough, not that far away, 130. Other things are very bad, right? So this is a very simple forecasting exercise, and you could extend this into multiple different data sets or domains and try to forecast future data using past historical time series. Thank you for watching.